Right, so I've shared my whiteboard and I think you would be able to see that. Yes, okay. So let's talk about differentiation today. We know how to differentiate things, but the important part is that what exactly is differentiation. So let's talk about that first. What is differentiation? Okay, let's talk about this. Now let's say you have a curve and you are interested in knowing the value of gradient at different points. For example, at this point, or let's say at this point. And you know that the value of the gradient would be different for different points on a curve, unlike a straight line. For a straight line, we are finding the gradient and we know it is going to remain same throughout the line. But for curves, the gradient is different at different points. So for finding the gradient in case of a curve, we differentiate. For example, let's say if the equation is y equals x squared, I will differentiate it and I know that the derivative would be dy by dx. And how to write it down? We can write it down as 2x. Now I can plug in different values of x. This value is 0. This would be -1. This is 1. If I'm interested for finding out the gradient at this point, I can plug in -1 here and this would give me -2. So -2 is the gradient of this curve at the x coordinate x equals -1 and so on. So this is the basic idea about differentiation. If I'm interested in knowing the derivative at this point, so I'll plug in 0 and that would give me 0. And I can see that as well. If I make a tangent line at the point 0, I would get a horizontal line. And if a line is horizontal, it has no slope. If it has no slope, then obviously the gradient is going to be 0. So this is how we link differentiation with gradients. They are linked, and you'll see we'll be using differentiation time and again for such questions. Okay, let's talk about the topic properly. So let's talk about how to define or how to denote differentiation. What is the notation for differentiation? So we have multiple ways of writing it down. You can write it down this way: dy by dx. You can write it down this way: f dash of x. You can write it down this way: df by dx. You can write it down as y dash, or you can write it down as y1. Now in questions which we'll be doing shortly, you will see this is also a way through which they are denoting differentiation. And we know, we'll talk about it obviously, but we have second derivative, third derivative, and higher derivative. So according to that, this number would change. If it is second derivative, it would become 2. If it is third, it would become 3. So we will be using this type of notation at most. So just remember, if you have a number written right here, they're not talking about different variables. They're talking about the same variable y and its different derivatives, like first derivative, second derivative, and third derivative. Okay, all right. So this is how you can just, write down or show differentiation, right? So let's talk about the formal definition of differentiation. Now, when I was talking about limits, I told you we use limits to define differentiation as well. For example, let's write down the definition first and then I'll explain this. So dy by dx can be written as change in function f of x plus h minus f of x divided by h, where this limit h is approaching to 0. Okay. Now this is a formal definition of differentiation. What is happening here? This is the value of function at x plus h. H is a simple number, okay? and it is approximately 0. It is not 0. This is why we're using limits. Okay, I've told you earlier as well. If we are just substituting something, there's no point of writing it down this way. When we write down limit, something approaching to some value, because we also write it down as if this value is going to infinity. So it cannot be infinity. Actually, it would be a very, very big number. So when we are saying limit h approaching to 0, it means that h is going to be a very, very small number, such that you can think about it as if it's 0, but it's not actually 0. So what is happening here? In order to define differentiation, we are basically finding the change in functions divided by h. Let's talk about it this way. For example, I'll make a line. Let's say this is a line, okay, and I'm interested in finding out its derivative. So this is a point. Let's say this is x, and then we have another point. Just imagine that it's a zoomed in version of this line. This is point x, and this point has the x coordinate x plus h. So this means that this difference is basically h. Okay. Now what is happening? How are we calculating the derivative? So we are calculating the derivative this way. We need to find the value of function at x. It would be f of x, and the value of function at x plus h would be f of x plus h. We are taking that difference and we are dividing it over the difference of the x coordinate. So it is basically how we find simple gradient. We know that we do y2 minus y1 divided by x2 minus x1, but we are doing that for lines. This thing can be used for curves as well. For example, let's imagine that this is a curve. If I take 2 points very, very close to each other. Why am I saying very, very close to each other? Because the difference in these 2 points is just of h, and h is approaching to 0. So this is why we're taking limit h approaching to 0. And if I zoom that thing in, it would approximately look like a straight line. So h is this small that if I zoom in a curve, I would be able to see a line. Okay. So that is why we are using this definition for all the curves, for all the lines, and for everything. It's not for a straight line only. This can be used for a curve as well. Yes. Is that okay, Ahmed? By dividing by h if we are finding their difference. Okay, no, 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 no. We're not finding their difference. You know how to find out gradient? We do m equals y2 minus y1 divided by x2 minus x1. Change in y with respect to change in x, okay? It is basically the change in both of them, and that is how we get it. dy is also talking about the change in y with respect to change in x, okay? So it is the change in both y and x. Yes. You get this now? Okay, all right. So it's just a formal definition and it's completely fine. It would be coming as it is. You will get to know more about it once you enter your, university life and everything. But for now, just for the sake of completeness, I wanted to talk about this. This is how we can define differentiation formally. Okay. Just imagine you have a curve and you are zooming in to the extent that this curve, not this curve, all the curve, but this small part between this curve, it would look like a straight line. The difference is this small, that the difference is approximately of 0. So you can imagine that if you zoom that thing in, it would look like a straight line, and then we can use this logic, this definition. So this is why I talked about this. Okay. Anyways, this is how we define differentiation formally. Let's talk about some more important things now. So we'll be using that curve. And yeah, let's talk about how to differentiate functions. Okay. Now we need to understand some general rules. I would not talk about too many because we'll be talking about more while doing questions. And we know how to differentiate in general. General rules of differentiation. So let's assume that we have a function, let's say y equals x to the power n. This is a function, n is any number, and you've been asked to differentiate this. So how do we denote differentiation? We write it down this way: dy by dx equals, and the rule says that this power would come here. So n x, and the power of x would now become old power, that was n minus 1. So this is how we differentiate in general. Now for different values of n, the values of the derivative would turn out to be different. For example, let's say you have y equals x. If you have y equals x, you know, if you start applying this definition, this would take time, but let's do it for the sake of completeness. The power is 1, x, and the new power would be 1 minus 1. So it would be 1. So in general, we know if we have a constant term, sorry, if we have a linear term, by linear, I mean the power of x is 1. So in that case, we are going to get 1. Okay, let's talk about another example quickly. So let's say you have y equals c, and c is any constant. This time around, we have a constant term. So again, I'll be doing it through the same logic. I can write this constant term as x to the power 0, because x to the power 0 would be 1. I'll multiply this 0 here, so it would become 0. So when we differentiate any constant term, the derivative is 0. When we differentiate any linear term, the derivative is whatever the coefficient of that linear term is. This time around it was 1. If it was 2, I would have had it in 2. Okay, so it depends on the coefficient. But every time we are using the basic rules, but obviously by now we know how to differentiate, so we can just do it directly. There's no point in writing it down this way and doing it slowly. We know if we have a constant, the derivative would be 0. We know if it is a linear term, it would be 2. Okay, and then we'll talk about the complicated examples once we enter past paper questions. Okay, so are you okay with this? This is how we derivate in general. Yes, Ahmed, any questions? Okay, all right. Let's talk about how to differentiate trigonometric functions and inverse trigonometric functions. So we have some quick formulas for that. Okay, let's talk about trigonometric functions now. Okay, now we have some trigonometric functions, some basic trigonometric functions, and we need to see how to differentiate them. Let's say you have sine of x. Let's say we have cos of x. And let's say we have tan of x. In order to differentiate sine of x, it is very simple. Dy by dx is cos of x. Then dy by dx is minus sine of x, and then for tan x it is dy by dx equals secant squared x. Okay, this is how we differentiate a simple function. Let's talk about an example and then things would get clear. Let's say you've been asked to differentiate y equals 2 cos 3 theta. Okay, now obviously this variable could be x, it could be theta, it's completely fine. All we need to understand is one is dependent variable and the other one is independent variable, and that is it. Again, in order to define it, we write it down this way: dy by d
Okay.
theta. Yes.
Yeah, so minus 2 sine, sorry, 6 actually.
Very good.
The
Yes. Excellent. Okay, 2 was as coming
differentiate,
as
yeah,
it is. Very well done. And then the derivative of this part would be 3 and it would be sine
sine 3
3
theta.
theta. Very good. Minus 6 into sine 3 theta. So we need to be careful with this part. Excellent. Okay. So yes, that is how we differentiate trigonometric functions. Let's talk about what we do for inverse trigonometric functions. Okay.
For arc sine, sine inverse of arc
Yeah,
sine, right?
inverse.
Right. So that is, there is like a from 1 by root something, root x minus x squared minus 1, something like that.
You're talking about the derivative?
Yeah, derivatives of arc,
So
x
it's
sine and arc cos.
y equals sine inverse of x. Okay. So we have some direct formulas, and let me write down all the functions first. Cos inverse of x, and then it is tan inverse of x. You won't be able to find too many questions from this part particularly, but just for the sake of completeness, I wanted to talk about it. Okay, just so we know this, because in NET obviously you won't be having the data booklet, so at least you should know the formulas. If something comes, you should be able to do it. It's there in the book as well. Okay, so how to differentiate this? Dy by dx is basically going to be 1 divided by under the root 1 minus x squared. Okay, and then we have dy by dx. This would be, the difference is again of minus sign, minus 1 divided by under the root 1 minus x squared. And then for tan, we do it this way. You would be able to relate to these formulas if you're studying P3 at the moment. Dy by dx is basically, specifically with this last one, 1 divided by 1 plus x squared. Okay, Ahmed, are you studying P3?
Yes.
So
I'm studying
did you cover integration?
Yes.
Okay,
Yes.
so you would be knowing about that tan inverse rule. If you are to
Yes.
integrate something of this
Can
type,
you?
let's say 1 divided by x squared plus a squared. So for this type of a thing, we are using tan inverse, right?
Right. But basically, the whole power is squared, right? So
It's x squared
we
plus
can
a
shift
squared.
it up to make it easier. If the power was just 1,
Hmm.
then no, I don't think we used tan inverse. Actually, no, we didn't.
Are you appearing from Cambridge board?
Yes, Cambridge board.
Right. Okay. All right. Okay. It's okay. But yes, since I was doing some past papers with one of my students, so we do use this. Okay. I'll send you the rule.
Actually,
Maybe you would be.
yeah, maybe because you can solve this question by through other methods as well, right? But I think we
No,
use
for what
arc
other
sine
method?
and arc cos integration. No,
No.
we can
For this
easily
question,
shift this up. The whole power square.
No, you cannot do that actually, because if you're using, I am not able to hear you properly. But if you're, are you talking about the natural log rule, where you have the derivative of the denominator in the power?
No. Actually, just we can continue. We may
Okay.
have done it. I just want to look at
All
it,
right. Okay. Okay.
and
Okay.
I will confirm it by tomorrow.
All right. Okay. 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 Right. Okay. So this is how we basically do it. But for as far as IT is concerned, just learn the formulas. That is it. Otherwise, you won't get to see too many questions from this part. Okay. Right. Let's talk about some more important things. Okay. We have one last thing left, and then we need to do the applications. Okay, and this is the derivatives of exponential and logarithmic functions. So you would be knowing that as well, but okay. Now it says for the exponential and logarithmic functions. So let's do it. Okay, now if the function is exponential or logarithmic, how do we differentiate it? So I'll tell you. If let's say y is equal to e to the power x, or let's write it down this way, e to the power f of x. Okay, it could be anything in the power, it could be x squared, it could be anything. So how do we do it? For finding the derivative, we do it this way.
So
Mhm.
e of f of x into f dash of x.
Very well done, excellent. Okay, perfect. Okay, this is how we do it. And then let's say we have, this is very important, we have a to the power x, or you can think about it this way for this as well. Let's do it once only. Yes.
Right. I did this yesterday, so I did. What was it?
Okay, so for this, we are doing it this way. Again, this would come as it is. The rule is same for this one and this
Right,
one.
right. So it
Okay.
would be something f dash of x into lim of a.
Yes, very good. F dash of
Right.
x and then natural log of a. Very good. Okay, perfect. And then if we have natural log of f of x, then how do we do it? So we do it this way. 1 divided by whatever we have inside the brackets multiplied by the derivative of the bracket thing, right? Whatever it is, we're writing down the derivative here and we are dividing it by that function directly. Yes. Is that okay? Yes, Ahmed, do you get this?
Hello.
Yes, okay, all right, okay. So is that okay? The exponential and logarithmic rules?
I got disconnected for a minute. Okay,
Okay,
lim of x. Yeah, this is all right.
okay, all right, okay. And then we know we have first derivative, second derivative, third derivative, and n derivative. So let's talk about that quickly because we'll be using that in questions. Higher derivatives. Okay. Now let's say whatever the function is, you've been asked to find the second derivative. So it could be something of this type. F double dash of x, y2, it could be d2y divided by dx2. So all these notations are used for showing second derivative. How do we do it? You first need to find the derivative. That would be dy by dx, and then you are supposed to differentiate this thing once again. Okay, so then we are going to differentiate this again, and this is how we do it. So whatever the question is, just differentiate it at once, and then if you've been asked to find the second derivative, differentiate it again. If it's third, you need to do it 3 times. If it's n, you need to do it n times. So this is how it would work. We'll talk about it once we enter the questions. Okay. Now the most important part is the applications of differentiation. Okay, that is why I did not erase that graph. Now the question could be of multiple times, and I'm pretty sure you would be knowing this already. So using differentiation, we'll be talking about equation of tangents. We'll be talking about equations of normal line. We'll see how to find if the function is increasing or decreasing. We'll see how to find the stationary points and all that. Okay, let's talk about equation of tangent. So for example, let's say this is a question. Let's consider this as example number 1. And we are talking about applications of differentiation now. Okay, and let's see how to find the equation of tangent line. Okay, now we are interested in seeing how to find the equation of tangent line. The curve could be any, it could be a cubic function as well, it could be a quadratic like this one. Let's see. Now you've been asked to find the equation of tangent at some particular point. Okay, they are going to give you the point. Let's say the point is 1, 1. This is the point. Okay, so how do we do it? First of all, we know that tangent would be a line, and the equation of any line can be written in this form: y minus y1 equals m x minus x1. This y1 and x1 are basically this x and y coordinates, and this is
That was not me.
yeah, I know that that's the other student. Okay, it's okay. And then we are looking for the gradient at this point. Okay, so the gradient would be at this point specifically, and I've told you earlier as well, the link in differentiation and gradients, you need to differentiate this function. It is y equals x squared. When we differentiate it, we are going to get dy by dx equals 2x. And for finding the gradient at this particular point, let's say it's this point, I'll plug in the x coordinate, that is 1. So that would give me 2, 1, and it's 2. Okay, so 2 is the gradient at the point 1, 1. So it's very easy. It would become 1 minus 1 equals 2 into x minus 1. Now we to simplify this, and it would give me y equals 2x minus 2 plus 1, and it is y equals 2x minus 1, right? So that is how you can find the equation of any tangent line, and it could be any curve. Step 1 would be finding the derivative, plugging in the x coordinate, that would give you the gradient of the tangent at that point. And then you need another point, so this would be given. You can just plug in this value, and that is how you can find the equation of tangent. Yes, any questions with this?
No.
Okay, let's talk about the equation of normal line. Again, we are going to talk about similar concepts. Okay. Now, when we talk about normal line, how do we define normal line? So let's say this is my curve, This is tangent. The green line is the curve. The red line is the tangent. And now I'm going to make the normal line. So normal is basically a perpendicular line and it is perpendicular to the tangent line. We know the relationship between two perpendicular lines. Let's say it's M1 multiplied by, or let's say it's M multiplied by M perpendicular. So this is the derivative of some line and this is the derivative of a line perpendicular to the first line. The product is going to be -1. So in short, if you know you have two perpendicular lines, if you know the gradient of any line, you can find the gradient of the other line by taking the negative reciprocal. Okay. So since we are interested in finding out the equation of normal at 1, 1, again the formula is same. Y minus y1 equals m x minus x1. Y1 and x1 are going to remain same. It is a point on the line and we can see that this point right here is there on the tangent as well and it's there on the normal line as well. It's both on the green curve, black line and red line. Okay, so it's on all the things. So we can use the same point, and for finding the gradient I can use this. This is the gradient of this line too. I'm interested in finding out the gradient of the perpendicular line or the normal line, that is the black line, and it would be the negative reciprocal of 2, that is -1 by 2. So y -1, because 1 is the y coordinate, equals -1 by 2 into x minus 1. And once I simplify this, I'm going to get y equals -1 by 2x plus 1 by 2 plus 1. And you can simplify this. So this would give you the answer. It would be 3 by 2. Yes. So is that okay, Ahmed? Please tell me honestly if you have any questions.
Yes. So what is gradient?
Gradient is the slope. Okay.
No questions.
No, it's okay. Gradient. Oh no. Okay, all right.
No, I was
So
joking.
yeah.
It's
Okay.
not
I'm
okay.
sorry.
You're telling me what
No,
gradient.
it's okay. It's okay. Actually, at this point, I can expect such questions from any students because when you have too much on your mind, so it's completely fine. I've seen those as well. So I did not know that you were joking. Okay, all right. So this is how we do it. Okay. Now let's say the question is about finding if the given function is increasing in a range or if it's decreasing, stuff like that. Again, we use derivatives and we know how to find this out. Okay. So if I talk about this curve again, the green one, I can see that it is increasing after 0 and it is decreasing before 0. And why am I saying this? Because the derivative after 0 would be positive. All the tangents would be drawn this way. Let's say this would be a tangent. If I talk about another one, at this point, it would also be an increasing line. Okay, so all these lines are increasing, so the derivative would be positive. And since the derivative is positive, this function is increasing. And if I talk about before 0, this would be the tangent line. This is going to be the tangent line. So the line is coming down. It is a slope that is coming downward. So that is why it is a decreasing function. So how do we do it? Increasing/decreasing functions. In order to understand this, just know that the derivative for this part, dy by dx, would be greater than 0. And at this point, dy by dx would be less than 0. Okay. So this is how we define if a function is increasing or it is decreasing. The derivative should be greater than 0 at that specific point, or it should be less than 0 for decreasing. What if the derivative is 0? This is the most important and the last thing. Then we'll be talking about questions. What if the derivative is 0? This would imply the stationary point, that would be maximum slash minimum, or it could be the point of inflection as well, right? When the derivative is 0. Okay, now I'll tell you how to do it. So we know if the question is about finding the stationary points, how do we do it? We just find the derivative, we equate it to 0. We are using that new equation for finding the values of x, just so we can see what would be the x coordinates when it is a stationary point, and we plug in those x coordinates in the original equation for finding out the y value. Now that would just give you information about stationary points. How to know if that stationary point is a maximum point, if it is a minimum point, or if it is a point of inflection. So let me explain this quickly. Let's say it's a curve of this type. This is the maximum point. This is the minimum point. And then if I talk about the point of inflection, so you can think about the x cube graph equals 0. Okay. So you can clearly see that the derivative would be 0 at this point as well. Okay. But what is happening before the point and after the point? Both before the point and after the point, if I make the tangent, it is going to give me an increasing slope. It is increasing and this is also increasing. So the gradient is positive both before and after the point. That is why it is point of inflection. But if you look at this, this is the minimum point. If I find the derivative before this point, it would be decreasing. If I find it after the point, it would be increasing. So the sign is changing before and after the point for minimum and maximum points. This is a maximum point. The value of derivative at this point is positive. At this point, it's negative, positive and negative, negative and positive, 0 and 0. Okay. So this would be minimum, this would be maximum. And for finding it out if it's minimum or maximum, you can just take the double derivative, and if the double derivative is negative, it would be maximum. And if the double derivative is positive, it would be minimum, right? You know this, Samad?
Yes.
Okay. And for the point of inflection, the derivative, the double derivative would turn out to be 0. That is it. This is the only thing which you need to understand. So I'll quickly write it down. Double derivative would be less than 0 for maximum, and double derivative would be greater than 0 for minimum. And for the point of inflection, double derivative is going to be 0. That is it. And you have 3 examples. This is point of inflection. This point is minimum point, and that point is maximum point. That is it. Okay. So this is how we use differentiation in different things. All right. Now let's talk about some questions, just so everything is clear. So I'll stop sharing the screen. And I am going to take out the PDF. Okay. So here's the screen. Okay. Let's talk about the first one. It's very simple. How do we differentiate cos of x? So I just told you, for different trigonometric functions, we use different rules. If you have cos of x directly, if this x is x, like it's just x, you are going to write down minus sign of x, right? So it is the most simple case, and this is how we do it. Okay. If it was anything other than x instead of theta, we would have differentiated that part as well, and we would have multiplied that as well. Okay. But since it's just x, so cos x would give you minus sine x. Okay. That is how we talk about a simple question, but only your memory would be tested from this thing, that if you remember how to differentiate cos and stuff like that. Right. Let's talk about the second one. It's more important. Now we have a condition and we need to find the value of x. They're saying if the derivative of this function is equal to the derivative of this function, then what would be the value of x? Now it's very simple. You need to differentiate this, equate it to the derivative of this, and then find the value of x. Okay. So let's do it together. How do we differentiate the first function? It would become 9x squared plus 1. Why is it 9? 3 into 3 is 9, and then the power would become 2 equals minus 6x. Okay, and then the derivative of this part would be 0. Let's simplify this. 9x squared plus 6x plus 1 equals 0. We need to do it through middle term breaking. I need two numbers such that when I multiply them, I get 9, and when I add them, I get 6. So the two numbers are 3x and 3x. So it would become 9x squared plus 3x plus 3x plus 1 equals 0. I can take 3x common, so it would give me 3x plus 1 plus, and then we have 1, and then again 3x plus 1 equals 0. So I am left with 3x plus 1 squared equals 0. And the value of x is going to be what? Yes, it would be minus 1 by 3, right? We are not going to get two values. We're just going to get one value. It would be minus x by minus 1 by 3. So the answer is going to be B. Yes, is that okay, Ahmed? Anything that you were not able to understand for the first two questions? Yes, any doubts? Okay, all right, very good. Okay, then let's do this one. Now it says, if f of y is b y to the power 3, then which of the following is true? Now the variable is y. If we differentiate it with respect to x, we are obviously not going to get anything until and unless it's a partial derivative, but that is not the case over here. So this is going to be none. Okay, they are differentiating it with respect to x, but they are doing it for y. So that cannot happen. The variable should be same. That is why the answer is none. Okay. The fourth part says the point.
Yeah, so
Yes.
yeah, I get it.
Is it?
Because otherwise, if we differentiate it in partial fraction, it would be dy by dx, right? Whatever the variable is
The
other than
variable
x,
is
right?
exactly, yes. Yes.
So can you explain like what this term is trying to say? Is this like f of y is equal to byq, right?
Yes. Yes.
So we are differentiating y
Mhm.
with respect to
X.
x.
Yeah, this is what they tried doing. Like they are differentiating
Okay.
this function that is in terms of y with respect to x. Okay, so we know we cannot do that. Like the answer would be clearly 0. The answer should have been 0 clearly. If the variable is different, the answer is 0. We do not have x here. But then when we talk about partial fractions, or sorry, not partial fractions, partial differentiation, so there you'll see we would be able to do it, but like, not at this level. Once you know enter your university life, and then you would be able to understand this. So in short, at your level, we can see we do not have x here, and still they are differentiating with respect to x. So the answer is going to
We
be,
actually do study implicit equations in
yeah, yeah,
Q4.
yes, yes, yes. I know implicit differentiation. Yes, but even that is not happening here. Okay,
Mm,
and this should have been in terms of y, even if it's implicit, because there you
right.
have both x and y mixed. Like you have yx plus x squared plus something equals something, right? So still you
Right.
are differentiating it with respect to x. The variable is same. And for writing it down, you're writing it this way, dy by dx. And for this part, we are just, doing it by product rule first, and then we are doing it
Product
whatever the
rule, yeah.
derivative is. But this time around,
Okay.
the situation is completely different. The variable is totally different, and they are differentiating it with respect to some other variable. That is why this would not be the case. Okay. All right. Let's talk about the fourth one. Now you can try doing it.
Now, if
Mhm.
I'm sorry,
No, it's okay.
if this was because a product rule is happening over there, right? If this was the incorrect answer, then we would have selected it, right?
Yes, say it again, please. I was not able to understand.
I'm saying if are we selecting none because there is no answer in the
Exactly. Yes, yes,
following?
yes.
Okay, okay.
Yes, yes. Okay.
No, I thought that there was, there was the term was giving the sense of, it can't happen. And it wasn't anything like that. There wasn't any answer, right?
Yes, exactly. Exactly.
Okay, okay,
Okay. All right.
okay.
So let's talk about the fourth one now. So it says the point at which the curve has gradient -2 is. Yes. Can you think about this?
Sorry.
Yeah.
Well, can you
Can
say it
you
again?
think about, okay, it's the fourth question. It says the point at
Okay.
which the curve this has gradient -2.
Hmm.
So you need
Okay.
to find the point
So,
basically. Yeah.
all right. So first, we will differentiate it. Get
Yes.
x is equal to -2, and then we'll get the y. Put the y into the original equation,
No,
and
they're saying you
we'll
need to
get the.
find the point at which the gradient is -2. The
Yeah,
gradient is,
that's what I'm saying.
so wait. So first we need to
First,
differentiate. I'm just following your
yes,
steps.
differentiate.
Okay. So 2x minus 4.
Yeah, put -2.
Okay, equated to -2, right?
Yes, equated to
Okay,
-2.
very good. Excellent. And then this would give you 2x equals 4 minus 2, and x would turn out to be
2. 4
1.
minus 2,
Yeah,
1. Sorry.
it would be 2 by 2, it would be 1. Okay. So now the
Yeah,
x coordinate is 1. There's no point in looking for the y
I'll put it
coordinate,
back.
because
Right.
yeah, yes, certainly you can do that, because but the only
And B,
answer,
yeah, there is.
yes, very good. Okay, the only
There's
answer,
only one.
yeah, very good. Okay, let's talk about the next one. So we have the sixth question here, and it says, if y is 2 by x, then what would be this? Okay. So we need to solve this. We need to find the double derivative. Now for this question, yes, you can do it completely as well, or you can just, think about it, and you would get the answer correct in that way, in that case as well. So we know that for this expression, first I need to plug in the value of y. That would be 2 by x plus 1 by
Should be
2.
C, right?
Yes, very good. It would be C.
Mm.
Excellent. Because the derivative of this part would be, it would be what? What would be the second derivative?
We'll shift x up, -1, -2. Then the second, that was the first derivative. Then the second derivative would turn x to the power -3, and then we'll shift it to the
Yes.
denominator,
Very good.
x power
Excellent.
3.
Very good. So for such questions, do not waste time in doing it completely. Just do it, okay? Because it requires logic rather than time.
Okay.
All right. Okay. Seventh one is interesting. Now we need to differentiate x to the power 9 with respect to x squared. Yes. So can you think about this?
Okay, differentiate x to the power 9 with respect to x squared.
Yes.
Okay, what does this mean?
This means that usually we are doing it with respect to x. Okay. So when I'll just talk about the simple case. When we are doing it with respect to x, f dash of x. So this is the variable, it's there. We are writing it down 9, and then x to the power 8. This time around, they want you to differentiate it with respect to x squared. So you will take out x squared from this part and separate the powers. I'll tell you. So it says x to the power 9. I need to write down this x to the power 9 this way, that I have x squared here, and now I need to multiply this thing with such a power that when this 2 is multiplied with that, I get 9. So can I write it down this way? I know through the power rules that the powers would be multiplied, and again when they would be multiplied, I would get 9. So x to the power 9 can be written this way. And now I can differentiate this directly. So the variable is x squared. It is going to remain as it is. The power is 9 by 2. It would come here. So 9 by 2. And then 1 minus the old power. So 9 by 2 minus 1. And you can simplify this. So this is 9 by 2. And then we have x squared. 9 by 2 is 4.5. 4.5 minus 1 is 3.5. That is going to be 7 by 2. So when 7 by 2 is multiplied with 2, 2 and 2 would be cancelled and the answer would be C. Yes, is that okay?
Yes.
Okay, very good. Let's talk about the next one now. Okay. Now you need to differentiate e to the power ex. So
Hmm. So we'll get e into ex into the derivative ex. Okay, is it b?
very good, excellent. Okay, this thing would come as it is, and the derivative of the power, that would be e to the power x. Very good. Right now it
Okay.
says yes.
Can you
Sorry.
go up?
Yes.
I
Yes.
actually want to think. Okay. Yes, then because the power is ex, so it will remain the same when
Yes.
like into f dash of x, it will remain same, right?
Exactly. Yes. Exactly. Very good.
You know, I did it instinctively the first time, and the second time I did it logically. It was
Okay.
like, okay,
Yeah. Yeah. I do understand this. Yeah, but you know the basic rules are going to remain same. For
right,
exponential functions, for logarithmic functions, the basics are same. So at times you can come across a very abnormal function, like right, like this initially looked very abnormal. Like this is not how we see it. We just talk about this thing. But then again, the rules are same, so we would be able to differentiate it. Right.
ex-
Let's talk about the next one now. Okay.
okay.
Okay. So it says the derivative of this. Yes, it's very simple. Now, ln e
One
is
second, one
okay.
second.
Sorry. Yes, yes.
I need to message this at 4 p.m. Okay.
Yes.
Yes.
So, what do you think?
Differentiate when. Okay. So basically, now where's the option? Okay, this will be 1 by ex cubed into 2x, sorry, 3x squared.
Yes, very well done. Excellent. Because ln e is basically 1. So, we would left with x cubed. And when we differentiate x cubed, it would give you 3x squared. Okay.
What happened to the 1 by ex cubed?
No, ln e would be 1. Okay. The value
Oh,
of
they would cancel it now. Sorry, I thought it was just Linux cube.
Yeah, no,
Right?
if
They
we
would
have
cancel it.
yeah,
Yeah.
yes, they would be cancelled. Very good. Okay. Then the 10th part is very easy. You need to differentiate a constant. The answer would be
0.
very good. Okay. Yes, 0. Okay. Let's talk about this. The 13th one. So it says given s is 980t minus 490t squared, the velocity at the instant t equals 1 by 2s. So did you study mechanics or you took S1 and S2 in A level maths?
So basically, M1 is done in AS, and
Mm-hmm.
S statistics is I'm going to do it
Yeah,
still.
because no, but you know, some of the students, like one of my students, she took S1 in AS and then now she's giving S2. So yeah, I was just
Right.
asking you that.
So no. For me, I took M1
In S1.
mechanics,
Mm-hmm.
S1, no,
Right.
and S1, right? S1 in A2, M1 in AS.
Yes. Okay. Okay. So you would be knowing this one, right? This is the function for displacement, and you need to find the velocity at this point. So we know what is the link in what is the link between displacement and
Differentiate.
velocity. Very good. Excellent.
This is my physics knowledge, but I haven't
Yes.
done this
Okay.
in mechanics.
Yeah, oh, but we
Or
do study this now, okay, at least now, because
okay,
I'm also teaching mechanics, so I was going through past papers. All right, so velocity is basically the derivative of displacement with respect to time. So how do we do it? It would be 980.
980
Mhm.
minus 2 into 490t.
Yes, very good. So it would be 980 again. 980 minus 980t. Okay, 2 to 490 is 980. And now we need to plug in 1 by 2. So 980 minus 980 by 2. And the answer is going to be, what? Yes, it would be 490, but which one? A, B, C, D. All of them are 490 actually. This is 49. It would be B, okay? Because we are
Okay.
finding velocity, it's distance over time. So be careful with the units as well.
Okay.
Okay, right.
Okay.
Now we have the fourth one. It's very important, and I would want you to think about it as well before I explain this. It says if x is this and if y is this, then now we need to find we have multiple expressions, and every expression other than the d has dy by dx. So it's good that we start finding dy by dx first, okay? We need to find dy by dx, but for this question you do not have, yeah, 1 second only. For this question you do not have y equals something in terms of x. You have dx in terms of
Right.
theta, you have y in terms of theta. So how do we differentiate such cases?
So, so sorry. We're talking about the variable a and b, right?
Yes, I'm talking about the variable
So,
theta. The variable is theta, a and b are constants, okay?
oh, a and b are constants.
Yes, a and b are constants. So we use the
Okay.
chain rule,
So
right? For such
the
cases.
chain rule.
Yes, for such, because you need to find dy by dx, but you have x in terms of theta and you have y in terms of theta. So for solving this, you can do it this way: dy divided by d theta multiplied by d theta over dx. You can differentiate it with separately. You can differentiate x with respect to theta and take the reciprocal, multiply them, and then you need to choose. So can you try doing this right now?
Okay, so differentiate x and differentiate y, then divide them
No,
is basically what
you
you're
will
trying to say.
differentiate. Yes, this is what I'm trying to say. But dy by d theta would come as it is, and for the second one we have d theta by dx. So when you will differentiate this, you would get dx by d theta. So you need to find the reciprocal of this only. And then you will multiply it with dy by d theta.
Okay, so d theta will cancel. So in short, divide
Yes.
them.
And we will
Right.
get dy by, no, because this is what the chain rule says, right? Okay, I'll tell you. You need to find, wait a second, let's erase all of this. The question says, if x is this and y is this, then, okay, and all the options have dy by dx in it. So I'm interested in finding out dy by dx. Now for finding out dy by dx, in this case, you can see we do not have y equals something in terms of x. We have two parametric equations and the variable x and y, both of them are depending on theta, okay? So this is how we solve
Okay,
parametric
okay.
equations, right? Okay, very
Right,
good.
this is a parametric equation. Yeah, you
Yes,
should have used that
yes,
word.
yes, because instead of t,
Okay.
we have theta here.
Yes.
So you can try solving this. I'll wait for 2 minutes.
Can we do it together?
Okay. All right. Okay. So what would be dy by d theta? Let's talk about that first. Sorry. Dy by d theta and then d theta by dx. Okay. So this is y equals b sine 4 theta. For finding dy by d theta, can you help me with this?
Yes. It would be 4b.
Very good. 4b sine.
That's 4 theta, sorry. So it would be b into, no, first of it's not a variable.
Yes, b is not the variable, but theta is the variable, right? So the power is 4. You need to multiply the power 4. B is a constant variable, so the constant is going to stay as it is. But let's say if the question was cos squared theta, so you multiply this 2 here, it would become 2 cos theta, right?
Mm-hmm.
So b is staying as it is as a constant. I'm not using b.
Okay, so sine would become into cos, right? Why did you not change that?
But I will change that, but listen to me.
Okay.
Okay, wait. If you have cos squared theta, y is this, okay? You are differentiating it dy with respect to theta. It would become 2 cos theta power 1 multiplied by the derivative of this thing. That would be minus sign, right? This thing, do you remember the bracket rule which we use for such functions? The thing inside the bracket is staying as it is, and we multiply the derivative of the bracket.
Hmm.
Let's say, let me write down the derivative first, okay? This would become sine cube theta, and now I'll multiply the derivative of this sine theta, which is cos theta. Is that okay now? I can explain this again if you have not understood this.
This is the new thing, actually. Okay, I've understood.
Wait a second. Let's say
So,
you have y equals sine
and this
cube.
is for only
Mhm.
parametric equations?
Yes, this is a parametric equation. We are used to
Okay.
writing down t and s as the variable. This time around we have theta, okay? But this time around, forget about parametric equations. This is a simple derivative. So let's say this is a function, x cube theta. Can I write it down this way? Y equals sine theta power 3. How do we solve bracket questions? dy by
Okay,
dx would be,
so,
Mhm.
right, 3 sine theta into
First the
cos
power would
theta,
become minus 1, right? It would become
2,
square, and
right?
then you'll write down the derivative of this thing, that is cos theta. Very good. So similarly, we had sine to the power 4. 4 would come here, the new power would become 3. Now this was your bracket function. You need to differentiate it,
Okay,
and it would be cos theta, okay?
got it.
Very good. So can you try doing dx by d theta, please? Let me
All
just
right.
write it down neatly.
So, So it would be 4a cos of theta to the power 3
Very
into
good.
minus sine
Excellent. Okay. So
theta.
dx by d theta is going to be 4a cos cubed theta and then minus sine theta. Okay. And now if I find dy by dx, so I'll be taking the reciprocal first, and this would become 1 by that. Okay. So I'll write it down directly. I'm interested in d theta by dx. D theta by dx would basically be 1 divided by this thing. Now I need to multiply them. So let's multiply it directly. I am going to write it down this way. So it's dy by dx equals dy by d theta multiplied by this. So it would actually be divided. It would be minus 4a cos cube theta sine theta. So I am going to erase this. And now we need to simplify this. So 4 and 4 would be cancelled. We would have b over minus a. Okay, what next?
And then cos would become into tan cube.
Yes, it is going to be second only. Yeah. So it would be, you can write it
Tan
down
and
this way.
cotangent.
Very good. Yeah, excellent. But 1 second only. So sine and cos theta and theta, I can write it down as whole power 3 multiplied by 1 second. Instead of doing
Just
it this
cancel
way,
it, right?
yes, exactly. Very well done. So this and this would be cancelled, this and this would be cancelled. And now we would have tan square
Tan
theta
square
directly, right? Very good. Now we are still not done
of a
of theta, basically. This is what we
of
are
theta, sorry.
getting. Yes. And this is dy by dx. Now I need to choose from all these options. So I need to simplify this first. So let's think if it could be a or not. I can take this a to the
It is
other side.
B,
It is a. It is a.
is it?
Okay.
Okay.
Because if it was
Sorry,
b,
yeah,
this
there's
would have been
equal to
plus.
sign before. Yeah,
Yes.
I didn't see that. Yeah.
All right. Okay. That's okay. But yes, so the answer would be, I can simplify this a into dy by dx equals minus b tan square theta. So it would be a. Very good. Okay, and then let's talk about this one. Now it says differentiate this. So again, we are to use the same rules. The rules are not going to change. How do we differentiate it? So we do it this way. We do 1 divided by whatever we have inside this natural log of x, and we multiply it with the derivative of this thing. So the derivative of ln x would be 1 by x. So the answer is going to be 1 by x ln x. C. Yes. Were you able to understand the last part?
Yes.
Sure.
Mm-hmm.
Okay. Now I'll zoom out and I'll scroll up again. If you have any questions, you can ask me. We have more questions as well. But first, I would want you to think about them once again. In case of any doubts, you can just ask me directly, okay? Yes, no questions from here?
No.
Okay, all right. Let's talk about a few more questions and then we'll talk about the rest tomorrow. Okay, now we have some more questions from the same chapter. It says, if y is, then we have an equation. Then which one is true? Okay, now it's very simple. I told you while talking about the topics that this means the first derivative, this means the second one. So this means the fifth derivative, the sixth derivative, the seventh derivative, and the
C.
fourth derivative. Very well done, excellent. The answer is going to be C because it is x to the power 6. So we know that when we are going to differentiate it for the seventh time, it would become 0. Very good. Think about the 18th question.
Product rule.
Yes, very good. Product rule. Excellent. So it says if y is this, which one is false? Okay, we are looking for the wrong one.
Should be A.
No, A is
Wrong.
correct. A is correct.
Yeah, false. Okay.
Yeah, we are looking for the false one
Second
basically.
derivative.
Just take a minute and think about this question. You would be able to understand this because it's just the product rule. And then once you get
Yes,
this,
then
now you know it's correct, right? You know it's correct. So for y2, just follow this.
Yes, differentiate that.
So we have two terms and both the terms would be differentiated by product rule. Okay, so this differentiation or y2 should have four terms. It has three terms only, but we have two here, and we know
Mm.
that when you will be differentiating y1, you would get v1 w1 from the first one and you would get v1 w1 from the second one as well. So this is also correct,
Mm.
right? This is also correct. Now
C is
imagine
wrong.
that you have you have b, you have three terms here and you need to differentiate it. So what do you think? This should give you six terms, right? Y3 should have six terms. It has three terms only and the middle term has coefficient 3. It means they have missed some term here. That is why it is false. So one way of doing
Okay.
it was doing it from scratch, just differentiating it again and again. Yes, that would be easier as well because we just have variables. But still, you can always use logic for MCQs and then think about the answer. Okay, so the answer is going to be
Right.
C. And always remember to be sure about this part if it's false or correct. Okay, or false or
Okay.
true. Sorry. All right. Okay. Then let's talk about one last question. It says if y is e to the power 20x, then what would be y4? Y4 is the fourth derivative. So you need to think about it. When we will differentiate it for the
Mm.
first time,
20 into 20 into, no, yeah, 20 into 20 into 20.
3 times or 4 times?
1 derivative, 2 derivative, 3, 4 times.
Very good. Okay, 4 times. So when you multiply it 4 times, the answer would be this. All right. Okay. So obviously we'll be accounting the zeros only, and that is how we know there's no point in wasting your time and doing it that way.
Actually, 1 second. 20, 20, 20, 20, 20, 20. 1, 2, 3, 4 is the rest. Okay.
Yes. Okay. All right. Okay, we have 3 minutes. Let's talk about the 21st as well. So we are looking for the minimum value of this function. What would be the minimum value? I've just told you. For the minimum value, we talk about the derivative
Second
rule.
derivative.
Yeah,
Second
but first
derivative.
you need to find the
First
stationary
derivative.
point. Yes, very good. First you need to find the stationary point. So it would be dy by dx. That would be 3x squared minus 6x equals 0. So I am going to take, sorry, this can be erased now. I will take 3x common. I would be left with x minus 2 equals 0. So x is going to be 0 and x equals 2. So we have two stationary points. Now we need to take the second derivative, plug in 0 and 2 to see if you are getting a positive second derivative.
Hmm.
So the
I
second
might get it.
derivative is going to be 6x, right? Second
Right.
derivative is 6x. And now when I'll plug in 2, I would get 12. And when I'll plug in 0, I would get 0. So for 0, this won't be a minimum point. It would be point of inflection. And for minimum point, I am going to use x equals 2. So
Second
it,
derivative would be -6. 6x minus 6.
oh yes, oh yes, oh yes. Very good. Sorry. Yes. -6. Excellent. Okay. Very good. So now when we will plug in 0, that is going to give me -6. And when I plug in 2, I am going to get 6. Very good. Excellent. Okay. So that is why the answer could be C or it could be B because X is 2. The exact value can be calculated by plugging in this 2 in the function. So just check that out. It would give us 8 minus 3 into 4 and that would be -4. So this is going to be the answer. B would be the answer. Yes. Is that okay?
Okay.
Sure.
The minimum value would be the U cup, right?
Sorry, say it again.
The U cup would give us the minimum value. This one.
Oh, okay. Basically, yes, you're right. Basically, this would be
Okay.
this would be a parabola, the second derivative, but this is basically a cubic equation, right? So we are going to have a
Hmm.
minimum value and a maximum value. And once we differentiate that, this is giving me a parabola. If that was your question.
Okay.
Okay. So anything that you were not able to understand in these and in this one, in both of them?
No, nothing.
Is that okay?
Yes, it's okay.
Okay, so I'll stop sharing the screen. I'll stop the recording.